Hello everyone, welcome back to codingscientist.com. You are watching World of Sensors using Arduino UNO and the sensor expansion board from Seed Studio Grow. Alright guys, in this lesson let's look at a very interesting sensor. It's called ultrasonic sensor. So what it does, so let's move on to this particular sensor. Pick it up from your kit. It looks like this. Above my picture, above my video, what you can see behind me, this is exactly it looks. So go ahead and pick up this and hook it up to port number D7. You might use any other digital port, but for this particular exercise I am using digital pin or digital port 7. So basically ultrasonic sensor is a non-contact distance measurement module which works at 40 kilohertz speed, right? When we provide a pulse trigger signal with more than 10 microcentimeter signal MUS through the signal pin. There are four different pins actually within the ultrasonic sensor, right? So one is the signal, one is the trig pin, one is the VCC, and one is the ground. So through the signal pin, when we are triggering more than 10 MUS, the range sensor will issue about 8 cycles of 40 kilohertz level and detect a echo, because there is an echo pin as well. So that detects the echo after hitting the particular object, right? So the pulse width, the PWM width of the echo signal is proportional to the measured distance. Wow, it might little bit be confusing for the newcomers, for the first timers, but if you Google up about how the ultrasonic sensor works, you can find ton loads of tutorials. Go ahead and understand the concept, right? So basically here the formula is distance equal to echo signal high time multiplied by the sound speed, right? That is approximately about 340 microseconds divided by 2. So anyways, now let's move on. Let's get connect to this. Let me show you how I connected, and then we will grab the codes. So this is the D7 port, and this is how your ultrasonic sensor looks like. This is the port where you hook up, and then there are, if you look back, there are three different chips. So you don't need to understand what it does, but this is the entire module. So it's pretty handy, looks beautiful, looks robotic kind of stuff. And connect this to the D7 port. If you see carefully, I have connected to the D7 port, right? So let me just turn it like this, and you can see I have connected to D7 port. Fine. So once you are connected, hook up your port, okay, to the USB, the Arduino port to the USB of your computer. And then let's move on to my GitHub. Open up your Google, go to my GitHub account, and you need to go to this particular section called Arduino sensor libraries, okay, not to the code. Go to my section called Arduino sensor libraries. In this, scroll down at the bottom, you can see ultrasonic sensor. So this library is a must. So without this library you cannot make your ultrasonic sensor work, right? So go ahead and download this library and make sure that you place the zip file inside your library folder of Arduino IDE where you install. It's ideally in your C drive. Within C drive you go where there's a program files and installation. Double click on Arduino, you can find the library folder. Inside the library folder, go ahead and place this particular file, the library. And then go to my code section. This is the code section, Arduino sensor projects, where I documented all the codes. Here you can go to lesson number 19, ultrasonic sensor.ino. If you go in here, it's about 23 lines of code, nothing great. It's easy to understand. Those of you from C++ background who have seen my other video lessons on Arduino Mega using C++ programming, go ahead and take a look. You will understand these programs pretty easy. Go to raw and then Control A, Control C, and open up your Arduino IDE, and this is your code. Alright, so once you paste it here, make sure to go to tools, go to Arduino, go to board, go to Arduino AVR boards, then select Arduino UNO, and again you need to go to tools, go to port com6, select com6, and then upload the code. Once you upload, let's see what we receive. All right, let me click the serial monitor on the right hand side, top right. You can see here, you can see my mouse, serial monitor, the lens kind of symbol, serial monitor. Once you click, there you go. Fantastic, guys. I am able to detect the distance. Cool. I'm just placing my hand in the front and see how it looks. So let me just share my other screen. Great. If you notice here, the distance changes, right? On the terminal you can see the distance to obstacle in front is how many centimeter it calculates. So let me place my hand, 1 centimeter, 2 centimeter, there you go. And let me just remove it, 20 centimeter, 25 centimeter. Let me change the direction towards other side, 33, 34. Let me just change the direction towards me, and it's 44. Let me change it reverse, it's 34, 33 approximately. Let me keep it close on the floor, towards the floor is just about 2 centimeter. Oh man, this is amazing, right? So guys, these sensors, you know, the ultrasonic sensors are very widely used in robotics applications, not just robotics but also, even in drones and stuff. So basically to avoid the obstacles around you, and there are also ton loads of interesting projects you can build using this sensor. So if you have any innovative idea and thoughts, do leave a message. I will help you to build those projects. All right guys, so I will get back to you soon in the next lesson. Goodbye.